Hi class, this is Course 3, Lesson 38, Properties of Equality. You recall, hopefully, that inverse operations are operations that undo each other. So addition will undo subtraction, and subtraction will undo addition. Multiplication will undo division, and division undoes multiplication. And we're going to use those facts to help us solve equations today. For properties of equality or addition, if A equals B, that just means if we have this something that equals something, then we can add C to both sides and we still maintain that equality. Same with subtraction. If we have two things that are equal to each other, then we can subtract the same number from both sides and we still maintain our equality. Multiplication, if A equals B, so if we have something that equals something else, then we can multiply both sides by the same number and we still maintain our equality. Division is a little different, just slightly. If A equals B, so same there, as long as we have something that equals something else, we can divide both sides of that equation by C, as long as C is not 0. Now C cannot be 0 because division by 0 is undefined. So all this says is that if we have an equation, we can add the same number to both sides, or we can subtract the same number from both sides, or we can multiply the same number on both sides, or divide this both sides by the same number, and we still maintain our equality. Okay, so we are going to solve x minus 4 equals 18, and we're going to justify the steps. Now you have been asked up to this point to do this mentally in your head or to figure it out by inspection, and now we're going to use properties of equality. So the steps that you'll do, 1, you'll choose the operation that isolates the variable. Okay, so isolating the variable means the variable should be alone on one side. Okay, so we want to make it isolated from everything else. So get the variable alone on one side and then perform the operation. Okay, so we're going to choose the operation and then we'll perform that operation to both sides of the equal sign. Okay, and we're going to justify the steps. So I'm just going to rewrite the problem down here. X minus 4 equals 18. Okay, and then I'm going to do this. I'm going to say, okay, here's my variable. So this is what I need to undo right here. And that you don't have to do that. I'm just doing that to illustrate what my thought process is. So I have a variable here. I'm currently subtracting 4 from that variable. So the inverse operation of subtracting 4 would be to add 4. That's 1. I figured out that step 1 is I'm going to add 4. Okay, now I need to perform the operation to both sides of the equal sign. This is exactly what I want to see on your paper. You're going to write down the initial problem, and then you are going to perform the inverse operation on both sides, and you are going to show your work. Show work. Okay, this is a very important step. So we decided we need to add 4 to undo the subtracting 4. So we're going to add 4 here and over here. Then we're going to draw a line, and if we add down, x stays, but a minus 4 and a plus 4, that ends up being 0. So I'm just going to put a big 0 there. You don't have to do that. The equal sign comes down, and then this becomes 22. So we can check our work. Does 22 minus 4 equal 18? Yeah. Now justifying the steps right here, all you have to put is add 4 to both sides. And then the last step, you simplified. That's it. Okay? We're going to go through just a few more examples, and a couple that if you want to participate with, you can, and otherwise you don't have to. So here are 2 problems that we will solve. And again, identify the operation that will isolate the variable. So my variable is here, it's x. Currently I'm multiplying x by 3. So I would need to do the inverse, which is dividing by 3. Now I can write that like this: a fraction bar and a 3 and a fraction bar and a 3. Now I divided both sides by 3. And the coefficient here on the x term, that will divide out. So 3 divided by 3 is just going to leave you with x equals. And then I need to work this out over here. 3 will go into 38 and 1/10. 1, 3, 8, 6. Let's see, that'd be 2, 1, and put my decimal out. And 3, that'd be 7. So x equals 12 and 7/10. Over here, now this might look funny to you, but this is, if I rewrite it, well, if I rewrite it with the correct numbers, rewrite it with 2/3 x equals 3/4. Okay, so there you go. Now, you are multiplying the x term right now by 2/3. So we would need to use the inverse of multiplying by 2/3, which would be dividing by 2/3. Okay? Now, when you divide by 2/3, what really happens? You multiply by the reciprocal. Okay, so if you have a fraction here, we're going to multiply both sides by the reciprocal. That's a P. Okay, multiply both sides by the reciprocal. And let me show you what happens. If I multiply this side by the reciprocal, 3 2's, and I multiply this side by its reciprocal, 3 2's, what happens over here? This 3 and this 3 will end up being 1, and that 2 and that 2 end up being 1. And so then on this side of the equation, all I have left is that x, and that's what I wanted. So then over here, we would multiply and we'd get 9/8, which you would need to simplify to 1 and 1/8. Okay, one other property is the symmetric property of equality. And all that says is that if A equals B, then B equals A. And that looks like, it's sort of like the commutative property in that you can rearrange things, but it's not. Okay, this is just saying that whatever is on the left side of the equal sign can be on the right side of the equal sign too. So if you end up with something that looks like 2 equals x, you can just switch those around and write it as x equals 2. Okay, that's the symmetric property. The x can be on either side of the equal sign and it still is a true statement. Okay, now I'm just going to go through 4 extra examples. If you want to watch as I solve them, you can do that. If you think, oh, I know how to do this already, not a big deal, you don't have to watch this. If you want to pause here and try to work them out and see if you get the same answer as me, that's great too. Okay, so not going to hurt my feelings any if you stop the video now, but I'll probably ask if you watched it if you ask me for help. Okay, so here I go. Problem over here. X is being divided by 4. So the inverse to dividing by 4 would be to multiply by 4. And I need to do that on both sides of the equal sign. So then this 4 in the numerator now and this 4 in the denominator will cancel each other out, and I end up with just an x on this side. And over here I would take 51 times 4 and I get 204. Over on the right, I have 1/2 times x equals 4/5. So I would need to divide both sides by 1/2 because division is the inverse to multiplication. But since it's a fraction, I'm really going to multiply both sides by 2. So I'm going to multiply by 2, multiply by 2. These will end up being just 1's, leaving me with just an x. And 4/5 times 2 is 8/5, and simplified I get 1 and 3/5. Okay, down here I am currently subtracting 72 from x, so the inverse to subtracting 72 would be to add 72. So I need to do that to both sides so that I isolate my variable, and if I add 103 and 72 I get 175. And that makes sense to me because 175 minus 72 would be 103. Okay, 4 times x equals 62, so I would need to divide both sides by 4, and I will do that using a fraction bar. These 4's will divide out, so I end up with x equals, now I'm going to work this out over here, 422, let's see, so 5, 20. Now at this point you can keep going with your decimal, or you can write it as a fractional remainder, so I'd have 2/4, which is 15 and 1/2. Okay, so hopefully that those are some examples that helped you figure out just exactly how to use the inverse to help you solve problems. I'll see you in class.